What is viscosity? Viscosity is a property of fluids that measures their resistance to flow. Think of it like this: for solids, the resistance between surfaces is called friction. At the boundary between a solid and a fluid, this resistance is called drag. Within the fluid itself, the resistance between its layers is called viscosity. Viscosity depends on the internal friction between the fluid's molecules. It measures how easily a fluid flows when an external force is applied. A fluid with low viscosity, like water, flows easily because it is thin. A fluid with high viscosity, like honey, flows slowly because it is thick. In short, viscosity is the internal friction within a fluid. It is a key property that measures how much a fluid resists deformation or flow. Let's explore this further. Imagine fluid flowing over a flat surface. Think of the fluid as moving in layers, each at a different velocity. When these layers move at different velocities, shear stress develops between them, similar to the friction between two sliding solid objects. This shear stress is most obvious near a wall. The wall exerts a significant shear stress on the fluid particles in contact with it, causing them to have zero velocity. This is called the no-slip condition. This stress is passed to adjacent layers, slowing down the flow near the wall and creating a velocity profile. The shear stress, tau, between fluid layers is closely related to the slope of the velocity profile, du dy, where u is the fluid velocity and y is the distance from the wall. In the free stream, the slope is small because the fluid layers move at nearly the same speed, resulting in minimal shear stress. Near the wall, the velocity changes rapidly, starting from zero at the wall and increase rapidly, leading to a large slope and significant shear stress. For most fluids, the relationship between shear stress tau and the slope of the velocity profile du dy is linear, with the constant of proportionality known as fluid viscosity, usually denoted by the Greek letter mu. Viscosity acts like internal friction, smoothing out velocity differences by increasing shear stresses in proportion to the velocity gradient. This linear relationship is described by Newton's law of viscosity. Fluids that follow this law are called Newtonian fluids. Some examples of Newtonian fluids are water, gasoline or petrol, and alcohol. Viscosity that is often denoted by the symbol mu, is sometimes called dynamic viscosity, or absolute viscosity, or just viscosity. Performing dimensional analysis on Newton's law of viscosity shows that dynamic viscosity mu has dimensions of mass, m, per length, L, time, t, or ml to the power of -1, t to the power of -1. The SI units of dynamic viscosity are Newton second per meter square, or Pascal seconds, or kilogram per meter second. There is another viscosity-related property of fluid called kinematic viscosity that measures how fast a fluid flows under the influence of gravity. Kinematic viscosity, often denoted by the symbol nu, is equal to the dynamic viscosity mu divided by fluid density ρ. The kinematic viscosity has dimensions of length square, L square, per time, t. Its units are meters square per second. In summary, dynamic viscosity, mu, or absolute viscosity, or just viscosity, tells us how much a fluid resists flow due to internal friction, while kinematic viscosity, nu, considers both this resistance and the fluid's density ρ to describe how it flows under gravity.